Hello everyone and welcome to your history and science lesson for today. So, as a historian and scientist, can I explain the key discoveries of Sir Isaac Newton? Right, we're just going to start with a quick recap, okay? So 2 weeks ago, we looked at the experiments of Galileo. Can you remember what he said would happen if we dropped a bowling ball and a feather at the same time on the moon from the same height, okay? Can you remember? Pause the screen and see if you can think back to what would happen. Right. So Galileo would have said, and we found this, didn't we? We observed this in the experiment that the astronaut did, that they would both hit the ground at the same time because there is no air resistance on the moon. And this is because the mass or weight of an object doesn't affect how fast it falls. So just because a bowling ball has a lot more mass than a feather, it doesn't make a difference, okay? All objects fall at the same rate. But the reason we see and observe objects fall at different speeds on Earth is due to the air resistance, okay? So that was what we learned 2 weeks ago. But what we're what we're going to find out today is, why do these objects fall in the first place, okay? So today's lesson, we're going to answer 3 important questions. Number 1, what happens to an apple when it falls off a tree? Number 2, why do penguins in Antarctica not fall off the bottom of the Earth? And number 3, why your goal kicks don't always go as far as you would like. Okay? Experiment time. So first of all, you're going to need to stand up. And after checking it's safe to do so, you're going to jump as high as you possibly can. So do that now. Okay, I'll give you a second. As high as you can. Lovely. What do you observe? Well, no matter how strong your legs are, eventually you will fall back towards the ground, okay? And this, as I'm sure you probably already know, is because of a force named gravity. However, although this seems obvious to us now, a little over 350 years ago, humans had no explanation, no scientific explanation for why this happens, okay? So, story time. In the summer of 1666, a British scientist named Isaac Newton made one of the greatest discoveries in the history of science. Legend says that Newton made this discovery while sitting underneath an apple tree. An apple fell off the tree at an angle of 90 degrees to the ground, okay, known as perpendicular. So you've got the ground here and the apple fell straight down, okay, perpendicular. And there's a picture of the apple hitting Newton on the head. The apple went on to strike Newton directly on the head. This caused him to start experimenting. And he started to notice that objects always fall straight down in this perpendicular manner. So, gravity. These experiments led Newton to conclude that the Earth must have a force in its center that pulls the apple towards the ground in a straight line, okay? Once the apple becomes too heavy for its stem to hold it, okay, so stem on the tree, the gravitational pull of the Earth brought the apple down in a straight line and landed on Newton's head, okay? But Newton also realized that it doesn't matter how heavy an object is either. If you let go of it, okay, or if what's supporting it drops it, the object will fall towards the Earth, okay? Now, as we know, it doesn't matter the speed, the weight, as we know from Galileo, the mass of that doesn't make a difference, okay? They all fall at the same speed. And you can summarize it like this. You can say, what goes up must come down, okay? That's a nice way to summarize it. I'm sure you've probably heard that before. Now, we've answered our first question, okay? So the apple, the gravitational force of the apple is too strong for the stem, it will fall straight to the ground, perpendicular, okay, in a straight line. We know that happens because of the Earth's gravitational pull. But what about the penguins, okay? Because we know that when an object goes up, eventually it will fall back down to the ground. But this raises an interesting question, which is, which way is down? And what about things at the bottom of the Earth, like penguins? So you notice here, you've got your penguins at the bottom of the Earth, haven't you? Here we have our penguins in Antarctica, okay? So we have a picture of a penguin going down. So why don't penguins fall off the Earth? What's going on? Can we work this out? So thankfully, penguins don't fall off the bottom of the planet, okay? And when we talk about gravity, up simply means away from the Earth and down means towards the Earth, okay? And let me demonstrate that with an image, okay? So here we have up, and you see moving away from the Earth in all different directions, okay? And you can think about this, think about a rocket, okay? A rocket has a tremendous engine, a huge amount of thrust, okay? And the reason it has that is that's because it needs to break free of the Earth's gravity, okay? In order to do that, it requires a tremendous amount of power. You see those launches where they have the huge rocket boosters and the engine just goes everywhere and it's incredible, okay? That is what it takes to break free of the Earth's gravity. And you can think of them as moving away from the Earth because they're going out into space. Now, down is towards, okay? So if you think about it, when you jump for a very brief moment, you exert some force. Your legs, when you did that earlier, you moved away from the Earth very slightly, okay? But then very quickly again, you went straight back down towards the Earth again, okay? So that pulled you back towards the Earth as gravity took over. The gravity became stronger than the force of your jump, and it took you straight back down again. So that's exactly what's happening. And penguins, although they're on the bottom, you think of them perhaps as on the bottom of the Earth, they don't have enough force to break free from the Earth, okay? So they stay within the Earth because the gravity keeps them there, okay? It keeps them towards the Earth. That's what's going on. Now, attraction. So gravity is the force of attraction between any two objects made of matter, okay? And both humans and the Earth are made of matter. So as a result, you have an attraction to the Earth. Okay, and any object that is on or close to the Earth's surface that is made up of less matter than the Earth will be pulled in by the Earth's gravitational pull. Okay, so this is why it doesn't matter where on Earth the object is, the Earth's gravity will pull that object towards it. Okay, so our penguins are staying put, which is brilliant. Okay, we love penguins. Right. Now, 3 laws of motion. As if discovering gravity wasn't enough, Newton went on to make some other major scientific discoveries, and we will now focus on what has become known as Newton's 3 laws of motion, okay? Now I have a question for you, pause the video here. What happens if you kick a football really hard? What happens? Right, so you are exerting a force in a specific direction, and that is the direction the ball will travel, okay? The harder you kick, the further the ball will travel. And I think we've all noticed this, haven't we? If you try really hard to kick a ball, it's going to go further than if you do a tiny little tap, okay? The harder you kick, the further the ball will travel, okay? Now, Isaac Newton studied all of this, okay? And he looked at the science behind what we observe in our daily lives, okay? So, Newton's first law of motion. The first law that Newton came up with states that any object in motion will continue to move in the same direction and speed unless forces act on it, okay? But what does that actually mean? Well, if you were to kick a ball into the air and suddenly all forces that resist its flight disappear, okay, imagine that, someone clicked fingers, forces disappear, that ball would fly forever in the same direction and same speed, okay? The ball would just keep going forever. It would never stop, okay? It's extraordinary, right? So there we have our footballer, okay? They kick the ball and let's say for some reason all the forces disappear. That ball is never stopping, okay? This is Newton's first law of motion. But fortunately for people who enjoy playing football, okay, you would run out of balls quite quickly, wouldn't you, if the ball never came back? The forces start to act on the ball immediately, okay? They act the ball immediately. These include air resistance and gravity, okay? So air resistance slows it down and gravity pulls it towards the ground, okay? So this is why your goal kicks don't go quite as far as you want, okay? Because you're up against gravity and air resistance, all right? Now, the second law of motion. So the second law of motion that Newton came up with states that the greater the mass of an object, the more force it will take to accelerate it. And this is summarized in the equation below. So here it says that force is equal to mass times acceleration. But you can think of it in this, you can think of this term, you can think of it as a car versus a bicycle, okay? Now, imagine, I think we can all of us can pedal a bicycle, can't we? So we're using the force of our feet to pedal a bicycle, okay? But what if I then turned around to you and said, right, can you pedal a car for me? So you can see we compare bicycle and car, okay? The bicycle has a lot less mass and the car has a lot greater mass, okay? So as it says, the greater the mass, the more force it will take to accelerate. So we might be well able to accelerate a bicycle with less mass, but we can't necessarily accelerate a car with just our legs and our pedals, okay? Because our legs don't get stronger, but the car gets bigger. The car is heavier, so we can't really move it, okay? And another way to look at this is to think of it like this, okay? In the football analogy, the harder you kick the ball, the further it will go. Now, let me show you what I mean by this. For those of you that are confident with your equations, you'll see. So for example, if we're keeping a ball, let's say we keep the mass constant, okay? So the mass is, let's say the mass is 1, okay? Now, the harder you kick the ball, so the force here is going to increase, okay? This is going to, because of the way the equation works, lead to greater acceleration. Greater acceleration means the ball will go further, okay? So you can see this equation. If you keep the mass constant, you keep the ball constant, when the force goes up, the acceleration goes up, which means the ball will travel further, okay? So basically, that's all you need to remember. The harder you kick the ball, the further it will go. All right, good stuff. And the third law of motion, as if Newton didn't do enough already, his third law of motion is this, okay? The third law states that, this is probably the most famous one, I would say. This is the one that most people can quote. The third law states that for every action, there is an equal and opposite reaction. And this means that there are always two forces that are the same, okay? Again, this is tricky to get your head around, so let's think about it. When you kick the ball, your foot exerts a force on the ball, okay? So let me show you here. This is your foot exerting a force on the ball, okay? The ball will then exert an equal and opposite force back onto your foot. So you see here, this is the ball exerting the force back onto the foot. So the yellow arrow is the ball and the red is your foot, okay? However, the reason why the ball will travel is because despite the fact that it's an equal force, okay, an opposite equal force, the ball has a much smaller mass than your leg, okay? And it will, since it has that, because it has a smaller mass in your leg, it will experience a rapid acceleration, okay? Causing the ball to fly through the air, just like we always see, okay? If you kick the ball hard, the ball will go through the air because the mass, your leg has a greater mass than the ball, okay? So you apply the force, even though it is an equal and opposite force, the ball is fighting back with a force, the ball will travel because your leg has greater mass, okay? Right, good stuff. And for today's work, I want you to find out a bit about Isaac Newton and his discoveries, okay? So bronze is going to be, I can produce a short biography of Isaac Newton and provide a basic explanation of the story behind his discovery of gravity, okay? So you can look into that story where he got hit on the head by the apple. You can tell me a little bit about Isaac Newton, what he did, okay? That's going to be bronze. Silver, as above, and I can provide basic scientific explanations of Newton's 3 laws of motion using either the football or bicycle analogy, okay? So I'm going to link in a video to the assignment that is going to show the same, go through the Newton's 3 laws of motion with a different example. This time it's using a bicycle, okay? It's a nice little video, but it might help you think about it in a slightly different way as well as the football one, okay? And then as above, and I can explain, this is where you're going to need a bit of research, I can explain the historical significance of Newton's discoveries, referencing his impact on the period known as the Enlightenment, okay? So I'm not going to go into detail. That's for people who really want to go into depth with this and still do all the science, but give me some historical significance too, okay? That would be brilliant. If you can look at, I mean, Isaac Newton, he really is one of the most famous scientists, extraordinarily famous, okay? And has just completely changed the world forever. So there'll be plenty of stuff to look into, okay? So best of luck. I hope you enjoy it, okay? And I will see you soon.